RockWorks is a tool for managing, analyzing, and displaying geologic data. The main screen consists of the following components. The title bar includes the version in year, month, and day format and top-shelf tools including how-to videos, search, license management, favorites menu, RockPlot 2D, RockPlot 3D, ReportWorks, Windows Switcher, Setup menu, Help, and Layout tools. The project folder bar is used for opening recent projects, creating new projects, or managing subsites. The project settings bar includes a summary of the coordinate system, the XYZ project dimensions and extents, tools to automatically set the project dimensions based on the data, tools to change the project or data coordinate projection system, tools to change the output units, a tab for adding a background image, and a tab for adding project notes or metadata. The Operations ribbon provides access to a variety of programs including borehole operations to create maps, models, and cross-sections, ModOps to create grid and block models from the datasheet and to manipulate models created from borehole data, utilities to create maps and diagrams from data within the datasheet, and graphics utilities to embellish and modify images and to create animations. The data management tabs include the Project Manager with a list of tables and RockWorks models and diagrams, the Borehole Manager tab that is used for entering, viewing, and manipulating borehole data that is stored within a relational database, the Datasheet tab that is used for entering, viewing, and manipulating data that is stored in a ledger-style database, the Faults tab that is used for entering, viewing, and manipulating fault data that is stored within the relational database, the Playlist tab that provides a tool for automating multiple operations, and the Execution History, which provides an audit trail for diagnosing problems. The license bar at the base of the screen shows the licensing status, copyright information, and two buttons that maximize the main RockWorks menu to fill the screen. Some of the main menu content can be decluttered by clicking on the small plus and minus buttons to hide and unhide content. This is especially useful when working with a single monitor system. Finally, please note that the tabs may be dragged to other screens, tiled within the main RockWorks screen, and hidden altogether. These configurations can be saved and restored with the layout tools located within the upper right corner of the main menu.
Step 1. Open a project folder. Open RockWorks by clicking the RockWorks shortcut on the desktop or click on the Windows Start button, type RockWorks, and choose the RockWorks item. If this is the first use, RockWorks will open the project in the Documents, RockWorks, Data, Samples folder within your Windows user folder. RockWorks data is either stored within the Borehole Manager database with tables for each type of data associated with boreholes, or in the datasheet with rows and columns of data. For this exercise, we will create a new project and import data into the Borehole Manager database. Click Project Folder New to display the Create New Project wizard dialog box. Accept the default location for the project folder, which in this case will be C:\users documents RockWorks data new project, or click on the yellow folder icon on the right to specify a different folder, or type in a new folder name. Click the Next button to accept the other defaults and proceed to the Project Coordinates tab. In the horizontal or XY coordinates and units section, verify that the coordinate system is set to UTM. Verify that the datum is WGS 84 1984 and the zone is set to 13 or the Northern Hemisphere. Verify that the UTM units are set to meters. In the vertical or Z units section, verify that the units are set to meters. Since the X, Y, and Z coordinates are set to meters, the output coordinates are also set to meters. Click Finish to display the confirmation dialog box. Verify that the settings are correct, then click Yes. Behind the scenes, RockWorks will create the new project folder and an empty SQLite database with the same name as the project folder. The system folder contains the database schema and should not be tampered with. Please, don't be overly concerned about making a mistake, because the Coordinates tab provides tools for changing the coordinate system and the associated parameters and/or data after the data has been entered. The new project has no boreholes or datasheet data, and the project extents are set to range from 0 to 100. We're now ready to start manually entering data, copy-pasting data from the Windows clipboard, or importing data from existing files, such as Excel.
One of the formats that RockWorks imports for borehole data is the multi-sheet Excel format. This format mirrors the database format. Excel sheets correspond to the database table in RockWorks, and columns correspond to different fields in each table. In this exercise, we will view the file in Excel and import it into the new project. Open Excel and choose the Samples Training 01.xlsx file from the folder C:users documents RockWorks data samples. Note that the tabs at the bottom of the Excel window have names that correspond with tables in RockWorks. The columns on the Location tab in Excel correspond with fields in the Location table in RockWorks. Required fields include the following: a unique borehole name or ID, easting and northern coordinates for the XY location, elevation for the default reference for calculating elevation from depth, often the ground elevation or top of PVC stick-up pipe, total depth representing the positive bottom hole depth or measured depth below the reference elevation. Close Excel and switch to the RockWorks window to import the Excel file. In RockWorks, choose the File, Import, Excel, Row-Based option. The Confirm window prompts to back up the database before performing the import. Even though the database is currently empty, select the Yes option to see how it works. Clicking OK on this menu will save the current SQLite database and menu settings to a zip file. The zip file is automatically stored within a subfolder titled Backup within the New Project folder. This file can be used to replace the current database if the current database is inadvertently corrupted. Once the database has been backed up, the Excel import wizard will appear. At the Import File Name prompt, click on the yellow Open Folder icon on the right side of the pane. Navigate up one level to the RockWorks Data folder. Double-click on the Samples folder, select the Samples Training 01.xls file, and click Open. RockWorks will read the Excel file and display the Block Selection tab. The Block Selection tab matches the Excel sheet names on the left column with the target RockWorks database table names in the right column. The names match automatically in this file, but you can click on the table name or blank cell in the RW Database Tables column to display a drop-down list of all the table names. When you are entering data to your working project, you may need to specify the matching tables. Click the Next button at the bottom of the window to proceed to the Data Coordinates tab, or click directly on the Data Coordinates tab. The Data Coordinates tab prompts you to specify the coordinate system of the incoming data. Verify that the horizontal or XY coordinates and units are set to UTM with a datum of WBS 84 or 1984 and 83. The zone equals 13 or the Northern Hemisphere. The units are in meters. Then the vertical Z units are set to meters. Please note that the input coordinates may be completely different from the previously specified project coordinates. RockWorks will automatically convert the Excel coordinates to the project coordinates during the import into the database. Click the Next button at the bottom of the window to proceed to the Location Fields tab, or click directly on the Locations Field tab. The Location Fields tab lets you assign the columns in the location sheet in Excel to the fields in the location table in RockWorks. By default, only the location table has this option enabled. If needed for other tables, enable this option for the selected table on the Block Selection tab, Show Block Mapping button. The button names match automatically in this example, and you can click in the right column for a drop-down list of available fields. In addition, the Location Fields tab lets you specify how to handle the import of new data to existing boreholes. The Borehole Overwrite Options section specifies how to handle data import for existing boreholes. Skip Existing Borehole will not import data if the borehole already exists in the database. Create New Borehole will create a new borehole if one already exists, so you can review the data before deciding which one to keep. Replace Existing Borehole will delete the existing borehole and import the new data. Update Existing Borehole will add new data to existing boreholes. Warn on Existing Borehole will display a message when a duplicate borehole is found, so you can specify the behavior separately for each borehole. Add Missing Borehole will add the borehole if it's not already in the SQLite database. Click the Import button at the bottom of the window. Click the Yes button within the Import Confirmation dialog. Confirm the Coordinate Reference System or CRS within the next dialog. Next, select the Yes option and we'll update the project dimensions to handle the newly imported data within the next step.
After creating a new project, the default project dimensions range between 0 and 100 for the X, Y, and Z directions. RockWorks uses these project dimensions to create most graphic output, including maps, cross-sections, and models. Although it's possible to manually enter these coordinates, it's much easier to let RockWorks scan the borehole database and automatically set the coordinate minima and maxima. So, click on the Scan option. Select the Boreholes option from within the Scan pull-down menu. Choose the All Boreholes option for the items to be scanned. Leave all of the other options set to their default positions and click on the green Continue button. Notice that the project output dimensions have been recalculated to represent the extents of the borehole coordinates, collar elevations, and total depths.
The types tables define the colors and patterns for the different types of lithology and stratigraphy, as well as other types of data. The Samples Training Excel file includes a lithology types table that lists keywords, colors, and patterns. It does not include a stratigraphy types table, so we will create one in RockWorks. The types tables are listed in the Project Manager pane on the left side of the main RockWorks window and in the header of each table that requires a types table. Double-click on the Lithotypes table in the Project Manager, or single-click on the Borehole Manager Lithology table to view the Lithology Types table. The data columns within the Lithology Types table are described as follows. The G-value is the number the computer uses for the lithology type when making models. Give each lithology a unique number. The keyword is lithology name or material type. USCS or USGS soil and rock types are often stored here. The pattern is selected from the RockWorks pattern library along with the foreground and background colors. The fill percent defines the portion of the column that the pattern will fill within strip logs. This is used to show weathering and erosional trends in 2D strip logs. The density is used for converting volumes to mass. Look up a reasonable density value for your material type. If the Show and Legend box is checked, the keyword and pattern will be displayed in legends created by the program. The optional HK and VK columns are used for specifying the hydraulic and vertical conductivities of the lithotypes. These values can be used by RockWorks programs to convert lithology models to hydraulic conductivity models. Notice that you can click on a column header within the Lithology Types table to sort on that column. For example, click on the G-value header to sort the table in ascending order based on the numeric value. Close the lithology table by clicking on the Close button within the upper left corner or the X in the upper right corner. Open the Stratigraphy Types table by double-clicking the strata types within the Project Manager or single-clicking the Strata Types button within the header of the Stratigraphy table in the Borehole Manager tab. The table lists 5 formations that were encountered within the imported Excel file. Notice that all of the formations have the same order and patterns. This is bad. RockWorks assigned these default values because the imported Excel file did not have a strat type sheet. Consequently, we'll need to manually add that information to the strat types table. Start by renumbering the order values to represent their chronostratigraphic order, with the youngest or uppermost unit having a value of 1.0. As you change the order numbers, RockWorks will resort the sequence from lowest to highest such that the listing now mimics a stratigraphy chart. Next, we'll need to assign unique patterns to each formation. Start by double-clicking on a pattern cell. This will invoke a pattern selection menu that allows you to select the pattern, its density or fineness, the foreground or line color, the background color, and the line thickness. You can also modify existing patterns to create your own patterns by clicking on the Edit button. We won't be covering the creation of custom patterns in this exercise. Instead, we'll direct you to the Help button to learn more about creating custom patterns. Repeat this process for each of the formations until you're satisfied with the results. Click on the Close button when you're finished.